Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the American Water Works Association, and we're looking at ammonium, what every operator should know. So what should they know? Ammonium is not commonly measured in drinking water, despite potentially being problematic in source water. Especially in groundwater, it creates large chlorine demand, as ammonium is converted to nitrogen gas and chlorine becomes chloride. Depending on the amount of chlorine added, it is possible for the combination of the two to form chloramines by accident, which can increase the risk of nitrification and biofilm growth in the distribution system. Some systems have seen such a dramatic pH drop due to nitrification as it's resulted in lead and copper corrosion. And that is specifically because chloramines stay in pipes for longer. The longer they stay in there, the more they make infrastructure deteriorate. So testing for ammonium is recommended only if you have the following issues in groundwater or your distribution system. And they're as follows: difficulty achieving or maintaining free chlorine residual, iron or manganese, color, hydrogen sulfide, H2S, rotten egg odor, difficulty achieving or maintaining free chlorine residual, drops in distribution system pH, copper or lead corrosion issues in the distribution system, nitrification-related symptoms in the distribution system, and some things you can do are ammonium treatment. And three of the most common options for treatment are discussed right here in the following table. In addition to those, you can also use reverse osmosis, ion exchange, air stripping, pH adjustment. And that might be more appropriate in some applications. For air stripping, it may be viable that the pH needs to be adjusted to 11, which may not be the cost effective for hard water. And we have the treatment types right here with breakpoint chlorination. And the idea here is to get enough chlorine to convert all the ammonia to nitrogen gas, and it's converted to chloride. In addition, chlorine is added to maintain free chlorine system, residual in the distribution system. Some things to take a look at those requires 8 to 12 milligrams of chlorine for every 1 milligram liter of ammonia to complete the reaction. Applying high doses of chlorine can lead to disinfection by product formation. Now, chloramination, if you have naturally occurring ammonia at about 0.5 or less, you may be able to add chlorine to form chloramines. And if you have color due to organics or TOC, then this may not be the best option, and you'll still have color and odor issues after the chlorine addition. And last but not least, the biological oxidation. Microbes use oxygen to convert ammonia to nitrate, and then into nitrate. It's called nitrification. And while nitrification is typically discouraged in distribution systems, the process encourages nitrification in treatment plants to avoid subsequent impacts on disinfection. So to consider that, in order to achieve biological removal of ammonia, you need to have water with adequate dissolved oxygen, and the process can lower pH and does use the dissolved oxygen, so you need a reactor vessel for the biological growth to remain as an attached growth process. So with that being said, that's ammonia and what every operator should know. Now, to know if there's ammonia in your water, you have to have it tested. That's why it's always a good idea to periodically test your water for high levels of ammonia.